Alright, so let's see how to use matrices to solve systems of linear equations. So in general, to solve a system of linear equations using its augmented matrix, we use elementary row operations. So these are the things we talked about in the previous video. We are allowed to swap two rows. We are allowed to multiply or divide a row by a constant. And we're also allowed to add two rows. So for example, if I have row 1, row 2, and row 3, I'm allowed to say that row 2 becomes row 1 plus row 2. Like I'm adding row 1 to row 2. Okay, so we're going to do these operations to the augmented matrix to get to a certain form. And then that certain form is going to give us the solution to the system of equations. So let's see what is that form. So the form that we have to arrive to is either called a row echelon form or a reduced row echelon form. So if we have our augmented matrix and we find its row echelon form, then we're able to find the solution to the system. So what is a row echelon form? A row echelon form a matrix is a row echelon form if the first non-zero entry in each row, reading from left to right, is a 1. So let's look at this matrix right here. What is the first non-zero entry in each row? Row 1, the first non-zero entry is this, and it is a 1. So row 1 satisfies condition 1. What about row 2? What is the first non-zero entry? The first non-zero entry is a 1, so it also satisfies it. Row 3, the first non-zero entry is a 1 as well, so that satisfies as well. And then this does not have a non-zero entry. However, the third condition for a matrix to be a row echelon form is that all rows consisting entirely of zeros are at the bottom of the matrix. So the row consisting in zeros at the bottom of the matrix. So this is correct. And now, what is the second condition that it has to satisfy? It says the leading entry, so this 1 is called the leading entry, is to the right of the leading entry in the row immediately above it. So the leading entry for row 1 is right here. What's the leading entry for row 2? It's this one. Is it to the right of the leading entry of row 1? Yes, it's to the right of it. What about the leading entry for the third row? It's 1, and it's to the right of the leading entry of row 2. So if this was a 1 right here, this matrix would not be in row echelon form because the leading entry of row 3 would not be to the right of this one. It would be to the left of it. Okay? Now, so if it satisfies 1, 2, and 3, then it's in row echelon form. Let's abbreviate that like that. Now, furthermore, if you notice that if you look at below each leading entry, all the values below each leading entries are 0. It just turns out that they're 0 because if they satisfy 1, 2, and 3, that's what's going to happen. Furthermore, if not only below each leading entry I have 0, but also above, so this is the leading entry, zeros below. This is the leading entry, zeros below and zeros above. This is the leading entry for row 3, zeros above and below. Then that's where it's row reduce or reduced row echelon form. Reduced row echelon form and row echelon form. We'll see that if we have an augmented matrix for a linear system, and if we do row operations to bring it in this form or in this form, then they're going to allow us to to solve the system. So our task is to find the row echelon form or the row reduced echelon form. So how do we do that? Well, we have to make a 1 in the top left corner first. So we have to make a 1 right here, and then make zeros below it, and then we look at the next leading entry, make that a 1, and then zeros below it, and so on. So the best way to learn is to look at an example. So let's look at an example. I have this matrix. So this is for a system, right? What would be the system? It will be 4x plus 8y minus 4z equals 4, 3x plus 8y plus 5z equals negative 11, and negative 2x plus y plus 12z equals negative 17. So to solve that system, we write the augmented matrix, which is this one. And now we're going to learn how to find, so we're going to find the row echelon form. So the row echelon form, the first task is to make a 1 for the leading entry. So this is the first non-zero entry, but it's a 4, so how do I make it a 1? Well, we know this. We know that I can multiply a row by negative 4, right? To make this a negative 8x, so that to make this a negative 4y, right? So similarly, if I want to make this a 4, I can just divide row 1 by 4. So what am I going to do? Row 2 stays the same, and then row 3 stays the same. I'm not doing anything to row 2 and row 3, so I might as well just write them. 3, 8, 5, negative 11, and then negative 2, 1, 12, negative 17. But what am I doing to row 1? So row 1, I'm going to divide row 1 by 4, and that's going to become row 1. So this is what this means. So row 1 is going to become row 1 divided by 4. I'm dividing row 1 by 4. I can do that. So then I'm going to have 4 divided by 4. That's 1. 8 divided by 4. That's 2. Negative 4 divided by 4. That's negative 1. And then 4 divided by 4. That's a 1. So I did not change the matrix. I mean, the matrix is changed, but it's equivalent. Okay? So this is my leading entry. I have it a 1. Well, the next step is obtain zeros below that 1. So I need to make this 3 and this negative 2, they need to be zeros. So these need to be zeros. So I'm going to work with this. So that means that I'm going to change row 2, and I'm hoping to get a 0 here. So row 1 stays the same and row 3 stays the same. I'm going to work on making this 3 a 0. So row 1 stays as it is, and then row 3 stays as it is. Now, looking at row 2, I need to add a multiple of row 1 such that this becomes a 0. So notice that if I multiply by negative 3 row 1, I'll have negative 3 times 1, which is negative 3. And then if I add row 2, negative 3 plus 3 is going to become of 0. So this is the right thing to do. I need to multiply row 1 by negative 3 and then add it to row 2, and that's going to become my row 2. So row 2 becomes negative 3 times row 1 plus row 2. Okay? So negative 3 times row 1 is this, and then I add it to row 2, and that's going to become row 2. This is the same as what we did in here. We said negative 4 times the first equation added to the second equation. That became my second equation that I'm working with. Which is this one, sorry. So when I multiplied the first equation by negative 4 and added it to row 2, this is what row 2 became. The y, the coefficient of y, became of 0. 0 plus y. We basically created a 0. So this is what we are doing actually with the matrix form. We're manipulating the equations, multiplying them and adding them such that we create 0, such that we eliminate a certain value or variable. Okay, so negative 3 times row 1. So negative 3 times 3 plus 3, that's a 0. Negative 3 times 2, that's negative 6 plus 8. Negative 6 plus 8 is a 2. And then negative 3 times negative 1, that's a positive 3, plus a 5, that's a 8. And then a negative 3 times a 1, it's negative 3 minus 11. Negative 3 minus 11 minus 14. Okay, so we made this a 0. That's good. But I need to have all entries below the leading entry 0. So now I'm going to work on making this a 0. Okay, so that means I'm going to change row 3. Row 1 and row 2, I'm good with it. This is a 1, this is a 0, so I'm not going to change it. So row 1 stays the same. Row 2 stays the same. So row 1 is 1, 2, negative 1, and a 1, a 0, 2, 8, and negative 14. And then how can I change row 3 such that this is a 0? So I need to add a multiple of row 1. I'm always working with row 1. I'm always working with the row with the leading entry 1. So I need a multiple of row 1 such that when I add it to row 3 becomes 0 here. So notice that I need to multiply row 1 by 2 and then I add it to row 3. So 2 times row 1 plus row 3, that's going to become my new row 3. So let's see. 2 times 1 is 2. 2 plus negative 2 is a 0. 2 times 2 is a 4. Plus row 3, that's a 5. And then 2 times negative 1 is a negative 2 plus 12. Negative 2 plus 12 is a 10. And then 2 times 1 is a 2. 2 plus negative 17 is negative 15. So there you go, I have my 0. So I am done with this, making this a 1 and zeros below it. I'm moving to the next row. So what is my next leading entry? Well, what's the first non-zero element in row 2? This is a 0. This is the first non-zero entry. And I need the first non-zero entry to be a 1. So this needs to be a 1. So how can I make it a 1? Well, I can divide row 2 by 2. So row 1 stays the same, row 3 stays the same. And then instead of row 2, I need this to be a 1, so I need to divide it by 2. So row 2 is going to be row 2 divided by 2. So row 2 becomes row 2 divided by 2. So let's copy first row and third row because they're not changed. And then in second row is the second row divided by 2. So it's going to be 0, 1, 8 divided by 2 is 4. Negative 14 divided by 2 is negative 7. So there you go. Now I have that the leading entry is 1. All I need now to get it in echelon form is that the entry below it needs to be a 0. So it needs to be 0. So how do I make this a 0? Okay, well, let's think. So I'm not changing row 1 or row 2. So 1, 2, negative 1, 1. 0, 1, 4, negative 7. And then row 3 is going to change. Now I'm working with row 2, right? So I need a multiple of row 2 such that when I add it to row 3, this entry is going to become a 0. So what do I need to multiply here such that when I add it to this is 0? Well, negative 5. Because negative 5 times 1 is negative 5 plus 5 is a 0. So this is going to be negative 5 row 2 plus row 3 goes into row 3. So negative 5 times row 2. Negative 5 times 0 is 0 plus row 3, which is 0. So this stays a 0. Good, because I did not want to change that. Then negative 5 times 1 is negative 5 plus 5. That's a 0. negative 5 times 4. Negative 5 times 4 is negative 20 plus 10, that's negative 10. And then negative 5 times negative 7, that's 35 minus 15, 20, I think. Negative 5 times negative 7, that's positive 35 minus 15, yes. So there you go, this is a 0. So I have leading entry 1 with zeros below it. Now we're moving on to row 3. What is the leading entry in row 3? What's the first non-zero entry in row 3? Well, it's negative 10, but I need this to be a 1. It needs to be a 1. So all I have to do is divide row 3 by negative 10 to make this a 1. So row 1 stays the same, row 2 stays the same. So 1, 2, negative 1, 1. Row 2 stays the same. But now row 3 becomes row 3 divided by 10. So negative 10. So row 3 divided by negative 10, that becomes my new row 3. So 0 divided by negative 10 is 0, 0 divided by negative 10 is 0, negative 10 divided by negative 10 is a 1, and then 20 divided by negative 10 is a negative 2. So is this in row echelon form? Yes, first non-zero entry in row 1 is 1. First non-zero entry in 02 is a 1 and it's to the right of this one. First non-zero entry in row 3 is a 1 and it's to the right of this one. And they all have zeros below it. This one has nothing below it. So this is the row echelon form. So how is this going to help us to solve the system? Well, all you have to do right now is write this in terms of the system. So from the third equation, remember that this was for your x, this was for your y, and this one's for your z, and this is for the free term. So if I write the system now, I get x plus 2y minus z equals 1. There's no x in here. Y plus 4z equals negative 7 from the second one. And then z, x is 0, x has 0 coefficient, y has 0 coefficient, z equals negative 2. So this is the beauty of this, what we call this a Gaussian elimination. This process is because now I can solve by back substitution. Solve by back substitution, basically I already have z. Z is negative 2. I'm going to go back into this one, and instead of z, I'm going to put what z is. And this is going to give me y. Y equals negative 7 minus 8, which is plus 8, so y is 1. And then I'm going to go back to the first equation. X, instead of y, I put 1, so it's going to be x plus 2 times 1 minus z, which is negative 2. So this is going to give me my x. X equals 2 plus 2, 4, so 1 minus 4, so x is negative 3. So the solution is the pair x, y, and z now, because I'm having 3 variables. X is negative 3, y is 1, and z is negative 2. So this is how we can use the row echelon form to get the solution for a system of equations. So I know this is a lot and it's new, but all it takes is practice. So let's see how to get the reduced echelon form and see how is that going to help us. So to find the reduced row echelon form, basically this is the same matrix, and we found that the row echelon form was, well, let's see what it was. It was this right here. 0, 2, negative 1, 1. I'm sorry, 1, 2, negative 1, 1, 0, 1, 4, negative 7, 0, 0, 1, negative 2. So you don't, okay, so I'm going to tell you right now. So you don't need to know how to find the reduced row echelon form, because you can always solve the system by just finding the row echelon form and then doing back substitution. But I'm just going to go over it once. So the reduced echelon form, it had to have zeros above the leading entry as well. So that's the only thing. So it has zeros below and zeros above. So I have my leading entries right here with zeros below it. So if I make this a 0 and this a 0 and this a 0, then I'm going to get the row reduced echelon form. So now if I want to make this 2 a 0, needs to be 0. I need to, so I'm changing row 1, row 2, and row 3 stayed the same. So 0, 1, 4, negative 7, 0, 0, 1, negative 2. So I'm changing row 1, and I need to make this a 2. So what multiple of row 2 added to row 1 is going to make this a 0? Well, I see that if I make this a negative 2 and then add negative 2 plus 2, I'm going to get a 0. So negative 2, row 2, plus row 1 becomes row 1. So negative 2 times row 2 plus row 1 is going to make it this a 0. So negative 2 times 0 is 0, plus 1 is a 1. Negative 2 times 1 is a negative 2, plus a 2 is a 0. And then negative 2 times 4 is a negative 8, plus a negative 1 is going to be negative 9. And then a negative 2 times negative 7, that's a positive 14, plus 1, that's a 15. So I made a 0 above the leading entry in row 2. So now to make this in row reduced echelon form, this needs to be a 0 and this needs to be a 0. So let's make this a 0. So I'm changing row 1 again. Row 2 and row 3 stay the same. 0, 1, 4, negative 7, 0, 0, 1, negative 2. I need to make this a 0. So I'm going to look at row 3. I'm using row 3 because I'm making a 0 in column 3. Row 3, what multiple of row 3 added to row 1 is going to make this a 0? Well, 9 plus negative 9 is a 0. So 9 times row 3 plus row 1. Okay, so 9 times 0 is plus 1 is 1. 9 times 0 plus 0 is 0. 9 times 1 is 9 minus 9, that's a 0. 9 times negative 2, that's negative 18, plus 15, that's negative 3. So there you go, I made 0. So the only thing that needs to be a 0 now is this 4, and then we're done. So I need to make this a 0. So I'm changing row 2. Row 1 and row 3 stay the same. So row 1 is 1, 0, 0, negative 3. And then row 3 is 0, 0, 1, negative 2. So let's look at row 2 now. I'm hoping to make this a 0 and it's in column 3. So what multiple of row 3 added to row 4 is going to make a 0 here? Well, this needs to be a negative 4. So negative 4 row 3 plus row 2. So negative 4 row 3 plus row 2 goes into row 2. So negative 4 times 0 plus 0 is a 0. Negative 4 times 0 plus 1 is a 1. Negative 4 times 1 is a negative 4 plus 4, that's a 0. And then negative 4 times negative 2, that's positive 8, plus negative 7, that's a 1. So now it is in row reduced echelon form because these are the leading entries and it has zeros above and zeros below. So if you look at this, if you recall, this is the identity matrix, is what we talked about on the second page. So, how is this going to help us to solve the system easier? This is called a Gauss-Jordan elimination. And if you look at this row reduced echelon form, this is going to give you the solution. Straightforward. This is for z, this is for y, this is for x. So x is -3. Y is 1. And z is -2. So the solution is -3, 1, -2. So you see how this is exactly the solution that we got by doing back substitution from the reduced echelon, row echelon form. So I hope you guys can see the difference in here. So once you start with the augmented matrix, if you do row operation and you get the reduced echelon form, so the one that does not have zeros above the leading entries, you can still solve the system by doing back substitution, so this kind of work. Or you can continue with the row echelon form and bring it into reduced echelon form and get the answer straight away. Okay, I'm going to let this sink in a little bit, and I'm going to do one more practice with you guys.